All right, in this video, we're going to solve some basic trigonometric equations, and they're linear because cosine, sine, and cotangent in these equations are not being exponentiated to any power other than 1. So the first thing you might do in a problem like this is just to note that we have to do the basic linear algebra, the basic algebra first. So if you were to call, just let c equal cosine of theta, for instance, this problem is really an algebra 1 problem where you need to do the basic algebra first, and then we'll get to the trigonometry. So we add square root of 2 to both sides. 3c equals square root of 2. So then we get that c equals the square root of 2 thirds. But again, c was really cosine of theta. Okay, so now you have to be a little careful here. Let theta be cos inverse of square root of 2 over 3. But you have to keep in mind this is not going to give you everything you want. Cosine is positive in 2 quadrants. Okay, cosine is positive in quadrant 1, and cosine is positive in quadrant 4. Angle theta, the first angle we're going to be given is the one in quadrant 1. Okay, it's going to give us that. If we want the one in quadrant 4, we're just going to have to make an adjustment. And it says solve for all angles, so we actually have some leeway in that case. So let's just go and find out what cosine of square root of 2, cos inverse of square root of 2 thirds is. About 61.9 degrees. So I'm going to write this as about 61.9 degrees. Okay, so let's call that like theta 1 because that's the first angle. Theta 2 would be the one in quadrant 4. Now you can express that in many ways. I'm going to express it as a negative angle, so theta 2 must be negative 61.9 degrees. And if we want to give all possible answers, we have to account for the fact that you can add multiples. You can add multiples of 360 degrees, and you'll rotate and get to new angles. So theta 1 is 61.9 degrees plus all multiples of 360. I'm going to let n be an integer here. And that's one family of answers. The other family of answers would be this. And we have to ensure that n is an integer. Okay, so it's a little tricky with your inverse trig buttons because they don't always give you, they're not going to give you everything you want. So we have to make an adjustment. Let's try this one here. So this says, so I'm going to let your, s be a stand-in for sine of theta. So we can do the algebra first. So this is 3s minus 2 equals 5s minus 1. Let's minus 3s from both sides. And let's add 1 to both sides. So this becomes a negative 1 over here. I get a 2s over here. So therefore I get that s is equal to negative 1/2, but of course s was really a stand-in for sine of theta. So this problem actually, I'm noticing, won't require a calculator because I recognize 1/2 as a special ratio. Now sine is negative in 2 quadrants. It's negative in quadrant 4. And it's negative in quadrant 3. Okay, so theta, the first angle I'm going to get, it'll give me an angle here. I'm going to have to note what that reference angle is and make an adjustment to make sure we get both answers. So if the sine of theta is negative 1/2, that means that sine inverse of -1/2 gives me that angle. The angle whose sine is -1/2 happens to be -30 degrees. So this here is -30 degrees, which tells me that my other angle must be over here in quadrant 3, where the reference angle is 30 degrees, and I need to add 180 to that to get 210 degrees. So our first angle is -30 degrees. The other one is 210 degrees. And to give all answers, we write theta 1 equals -30 degrees plus all multiples of 360. Theta 2 equals 210 degrees plus all multiples of 360, so long as n is an integer. And let's finish with this last example. So again, if we let c equal cotangent of theta, then this becomes 6c plus 11 equals 0. 6c equals -11. So that c is -11 over 6. But of course, that was cotangent of theta. So I think I'm going to use the reciprocal of cotangent and re-express this. If cotangent is -11/6, that must mean that tangent of that angle is -6 over 11. Now, one thing you might do that I didn't do above, you can basically ignore the negative if you want, if you just look visually at where you are. So let's note that tan inverse of +6 over 11 is going to give us a reference angle. Okay, so this is equal to, well, let's see. We're going to need a calculator for this. So let's type in tan inverse of 6 over 11. We get about 28.6 degrees. Okay, now again, we are in fact dealing with a negative ratio. Tangent is negative in quadrant 2 and quadrant 4. And what we've learned is that the reference angle for our solutions are 28.6 degrees. So that tells us that this angle here is 28.6 degrees. And the reference angle in quadrant 4 would also be that. Oops. Okay, so how do we express our answers? Well, we can do one of two things. We can say theta is equal to, we have to call that -28.6 degrees plus all multiples of 360. And that's, the first set of solutions, the ones from quadrant 4. The second set would be, well, let's think. If that reference angle is 28.6, I'd have to rotate that amount, which is 180 minus 28.6. So 180 minus 28.6, 151.4. Okay, plus multiples of 360, where n is an integer. So there's nothing wrong with expressing your answer like that. That gives two families, the ones from quadrant 4 and the one from quadrant 2. You can, in this particular case, be more concise. And what I mean by that is you could have said this, and this doesn't always happen. It happens often with tangent because the angles where the quadrants or tangent is positive and negative happen to be diagonal from one another or 180 degrees apart. If you want to be more concise, you can express all answers like this. Theta equals 28.6 degrees. And if you notice, if you add 180 to this, you get the other angle. So really, we could just start with one angle as like our first representative and then add multiples of 180 That's a concise way of representing all the answers. Both of these will produce the same set of angles that are solutions to our equation, so it doesn't really matter. But in any case, solving linear trigonometric equations and producing all answers. Those are 3 examples you can use. The first and the last involving a calculator, and the second one you should have been able to do without.